Welcome to the Monday session for week 7 of trigonometry. I'm sorry I wasn't able to meet with you live tonight, but we had some thunderstorms roll through and they have knocked out the local internet signal, and that I expect to be up within a few hours. And so what I'm doing for class for Monday on October 12th is that I will work some problems and post those solutions to the Blackboard course, where you're welcome to get them. Let me just mention a couple of things that are coming up in case they've escaped your notice. Not this Saturday, but the Saturday afterwards is the deadline for finishing test number 2. Now, test number 2 isn't even available to you yet, but you just want to keep that on your horizon. That's coming up, and so we need to be getting ready for that. The quiz number 5, I believe it is, but certainly quiz, that's due tonight on Alex, and so you want to get that wrapped up if you haven't already. And then a week from today will be the last quiz before the test. Now, the problems I'm going to work on tonight and post, let me show you those. These are just some problems that either I took verbatim from the review for test 2, or they are things that were kind of inspired by those, or questions that people have asked me. So I'll be working through a number of these problems, and those are the solutions that you'll see. There's a couple of things you'll want to have with you when you do that, probably. I have, of course, my sheet of double-sided sheet of trig identities, and actually I want to say a little bit about some of these just tonight before I go to problem solutions. And then I mentioned in class that if you go back, I think it's on week 5, you'll find a heading under the week 5 folder that says graphs or trig functions. And if you click on that, it actually opens up an OpenStax calculus book. And if you just scroll down a ways, you'll find this really nice graphic of the six trig functions. And by the way, that book is free to download and use. So it's not bootleg. You can take the whole book if you want, or you're free to open it up and grab a copy of these pictures. I use these because they're well drawn, and I can, if I want to talk about the sine function, I can just plop this down and say, remember the sine function has this kind of appearance, and you get a reasonable start on the picture. So that's what's coming up. That's what I'm going to be doing for most of tonight. But there's one thing I really wanted to hit last week, and I didn't get to it. So let me mention that just by way of explanation. The cofunction identities are these. For instance, the sine of pi over 2 minus x is the same as the cosine of x. And likewise, the cosine of pi over 2 minus x is equal to the sine of x. I'd like to explain why these are called the cofunction identities. Now, and then I'd like to draw in pictures and show you it's actually not that deep. You'll believe that these are true once you see what they're saying. But notice this: sine, cosine, it's always the cofunctions, tangent and cotangent, secant and cosecant, that are connected by means of these identities. So that's one explanation of why they're called the cofunction identities. Another explanation is that two angles are called complementary if their sum is 90 degrees in the degree system, or pi over 2 radians in the radian system. So I've just sketched a quick right triangle here. So take this to be a right angle, or 90 degrees, or pi over 2 radians here. And then I've got two angles marked out. One I'll call theta, the other one I call alpha. And In the degree system, the measure of theta plus the measure of alpha would have to be 90 degrees, or in the radian system, the sum of their measures would have to be pi over 2 radians. Now, whenever this is true, we say that the functions are complementary. Now, two angles are complementary if they sum to the measure of a right angle, and that's actually where the name for cosine or cotangent or cosecant, the co part of that name, where that comes from is the word complementary. And I just want to show you where that comes from and why we get the identities that we do. Let's take theta here. And relative to theta, this is the opposite side and this is the adjacent side. So if I were to compute the sine of theta, that'd be the opposite over the hypotenuse. Now, if I were to compute the sine of alpha, it'd be this thing marked adjacent. It's not adjacent to alpha, it's adjacent to theta, where you get adjacent over hypotenuse. But what if I took the cosine of alpha? Well, the cosine of alpha is the side adjacent to it, which I've got marked OPP, meaning that it's opposite theta. And the hypotenuse, it would go in the denominator. But notice these things are equal. So the sine of theta and the cosine of alpha are the same. And likewise, if I'd started with the cosine of theta, the cosine of theta would be adjacent over hypotenuse. That would be the sine of alpha. It'd be this over this. So then we use this relationship right up here. If you want to write it the way it is on the list of identities, pi over 2. Let's subtract theta from both sides. Pi over 2 minus theta is equal to alpha. So I could plug that in here. Cosine pi over 2 minus theta is the same as the sine of theta. And in the same way, you can easily show that the cosine of theta is equal to the sine of pi over 2 minus theta. And those really are the relationships that you have here in this first line of the cofunction identities. If you start with sine and you take the complementary angle, you'll get the cosine of the original angle. If you start with the cosine, if you start with an angle, take its complementary angle and compute the cosine, you'll get the sine of the original angle. So that's what we have. That's what we have right here. And it not only works for the sine and the cosine, it works for the tangent and the cotangent pair up like that, and the secant and the cosecant pair up like that. So these look maybe a little bit intimidating right at first, but when you realize that this angle and this angle are just the different corners in that right triangle, a lot of the mystery is taken away. So we'll have a chance to work with that a little bit more in the future, but I wanted to explain where that comes from and why it is, after all, that we have 3 of these 6 trig identities. Their name starts with co. Well, it refers to a complementary angle. All right, I'm ready to start working problems, and I hope you follow along.